Applications of linear functions. The goals for this lesson is to solve supply and demand problems using linear functions, solve cost analysis problems using linear function, and solve break-even analysis problems using linear function. We began by defining a supply function. First, if x is defined as a price, the supply function at the given price x is denoted by S of x, and the demand function at the same given price is denoted by D of x. And also, the equilibrium price is the value of x when S of x is equal to D of x. Likewise, if we define Q as a quantity, the supply function at the given quantity Q is denoted by S of Q, and the demand function at the same given quantity is denoted by D of Q. And also the equilibrium quantity is the value of Q when S of Q is equal to dQ. To illustrate this, let us consider the following problem. Kaito makes origami art for his people in his village. His supply and demand functions are given by S of x equal to 14x minus 95, that is the supply function, and the demand function D of x is equal to 105 minus 11x. First, we are asked to find the intersection of the 2 points, and then we want to compute for the price when the supply and demand are in equilibrium. Now, to get the intersection of two functions, we will just equate the two functions, that is solve S of x equal to D of x. So S of x is given by the expression 14x minus 95, and our D of x is equal to 105 minus 11x. Then we will solve for x. So to solve for x, we will put all expressions that contains x on the left-hand side of the equation. And we can obtain that by adding both sides by 11x. So we can cancel this 11x here. And then we also do that on the other side. So I have to add 11x here as well. And then also, I want to cancel negative 95 on the left-hand side. So therefore, I would add 95 on both sides of the equation. Therefore, by adding these two equations, I will have 14x plus 11x, which is equal to 25x, and then 105 plus 95 is equal to 200. So we will then solve the equation 25x minus 200. We can do that by dividing both sides of this equality by 25 to cancel 25. So we cancel 25. Now 200 divided by 25 is equal to 8. Therefore, x is equal to 8. And then we will compute for the y value. So to get the y coordinate, we are just going to plug in this value for x to any of the equations here. So for instance, we can evaluate our S of x at 8 to get the y value. So that is 14 times 8 minus 95. Solving for this will give us 17. So therefore, the intersection of the 2 points is the ordered pair 8, 17. Now to answer the next question, what is the price when supply and demand are in equilibrium? We're just going to use the definition that the equilibrium price is the value of x when S of x is equal to D of x. Now referring to our result in A, we got an intersection of 2 points by solving for the solution for S of x equal to D of x. So therefore, the equilibrium price is just the x-coordinate of the intersection of 2 points. So therefore, x is equal to 8 here. For letter C, we want to determine the amount of origami art available when the given system is in equilibrium. So to answer this, we are just going to evaluate our supply function at the equilibrium point, which we got to be 8. So we're just going to evaluate S at x equals 8. That is 14 times 8 minus 95. And this is equal to 17. So that means that we have 17 pieces of origami art. Next, we want to determine how many pieces of art can be supplied at the price of $9. So since we want to know the number of pieces that can be supplied, that means we are going to evaluate the supply function S at x is equal to 9. So we want to know the value of S of 9. That is 14 times 9 minus 95. Evaluating this will give us 31. So that means we have 31 pieces of art can be supplied at the price of $9. Then lastly, we want to know how many pieces of art will be demanded at a price of $9. So since we want to know the number of pieces of art that will be demanded at a price of $9, we're going to use the demand function D of x. So we are going to evaluate the demand function D of x at x is equal to 9. So we want to know the value of D of 9. That is equal to 105 minus 11 times 9. 105 minus 99 is equal to 6. So 6 pieces of art will be demanded at a price of $9. Now let's consider another example. Laura makes little girls' shoes from her home. If the demand for her shoes is given by the function dq equal to 81 minus 9q, and the supply function is given by S of q, which is equal to 4.5q. What is the equilibrium quantity? So the q here is the quantity. So to do that, since we are going to look for the equilibrium quantity, we are going to solve for the value of q when S of q is equal to D of q. So that is the intersection of the two functions. So we have 81 minus 9q is equal to 4.5q. To solve for q, we will put all the terms that contain q on one side of the equation, and those without will be on the other side of the equation. So we can do this by adding 9q on this side here and also on the other side. So adding 9q on both sides, we get 81 is equal to 4.5q plus 9q, and 4.5q plus 9q is 13.5q equal to 81. Then, so for q, let's divide both sides by 13.5. So 13.5 will cancel out. So dividing both sides by 13.5, you have Q equal to 81 over 13.5, which you can simplify to be equal to 6. That means that we need 6 little girls' shoes to obtain equilibrium. Now let us analyze the linear cost function. A linear cost function C is a function written of the form C of x is equal to mx plus b. The b here, which is the y-intercept, is the fixed cost that does not change. And m, which is the slope, is the marginal cost, which is the cost added by producing one more unit of the product or service. And the x here is the quantity of goods produced or length of time, etc. So x is the input. And mx, the first term here, mx is called the variable cost and depends on x. So to understand this, we will take a look at the following example. A telephone company charges its clients 50 cents for the first 10 minutes and then 8 cents a minute for each additional minute. Determine the cost function and then calculate the fixed cost. So to determine the cost function, we are just going to follow the formula C of x equal to mx plus b. And then we will identify what the slope is. So m is the marginal cost at which the cost, this is the cost added by producing one more unit of a product or service. So if you look at this one, we know that the telephone company charges its clients 0.50 for the first 10 minutes, and then a minute, and then 8 cents a minute for each additional minute. So this is actually the rate. So 0.08 a minute for each additional minute is actually the rate, and the fixed cost is 50 cents for the first 10 minutes. So that means that this 50 cent here will be our B. That would be the B in this case. And this 8 cent here per minute, this is the rate. So that would be our slope. And so therefore, the cost function is given by 0.08x plus 0.50. And then what is the fixed cost? The fixed cost is the y-intercept here, and that is equal to 50 cents. So the fixed cost is 0.50 for the first 10 minutes. The next, what is the marginal cost? This marginal cost is just actually the slope. That is just the slope. So in this case, if you look at the cost function, the slope is 0.08. So the marginal cost is 0.08 per additional minute. The next, how much would it cost to talk for 35 minutes? So to compute for that, we're just going to evaluate our cost function C of x equal to 0.08x plus 0.50 at x equals 35. So C of 35 is equal to 0.08 times 35 plus 2.50. Simplifying this will give us 2.5. That means it cost you $2.5 or $2.50 to talk for 35 minutes. Next, let's discuss the profit function. So given a quantity X and a price P, if R of X is equal to quantity times price is the revenue function and C of X is the cost function, then the profit function can be written as P of X is equal to the revenue minus the cost. Now the quantity when the revenue is equal to the cost is called the break-even point. To illustrate this, let us consider the following example. Johnny is launching his new record label company after initial startup fees of $10,000. It will also cost him $10 per record, but he plans to sell each record for $18. Determine the revenue and cost function. So the revenue function is R of X, and this is defined as P times X, where P is the price and X is the quantity. So the price, we know that the price is he plans to sell each record for $18. So the price per record is 18. So therefore the revenue will just be 18 per quantity or per quantity X. So revenue is 18X. Now the cost function C of X is equal to MX plus B, where M is the marginal cost and B is the fixed cost. So we know that it cost him $10 per record. That means that is our marginal cost, so 10x. And then B is the overhead cost. So he has an initial startup fees of $10,000. So that would be your overhead cost, so plus $10,000. So the cost function is equal to C of X equal to 10x plus 10,000. Letter B. How many records should be produced if Johnny wants to break even? Now, we know that the break-even point is the value of X when R of X is equal to C of X. So all we need to do is to solve for X when R of X is equal to C of X. Therefore, we have 18x is equal to 10x plus 10,000. And then we solve for x. So we can subtract both sides by 10x. Then we have 18x minus 10, that gives us 8x. And then equal to, so this 10x here minus 10x, that will just be 0. So that is equal to 10,000. So to solve for x, we divide both sides by 8. So therefore, x is equal to 10,000 over 8, and that is equal to 1,250. So to break even, Johnny needs to produce 1,250 records. Now, what will the revenue and cost be at the break-even point? That means that we are going to solve for R of X or R when x is equal to 1,250, or you also can solve C when x is equal to 1,250. We know that both of them will yield the same result because this is at the break-even point. And so just solving for R, because R seems to be easier. So R of 1,250 is equal to 1,250 times 18, or 18 times 1,250. And that is equal to 22,500. And then lastly, we want to compute for Johnny's profit after selling 1,800 records. To do this, let us first set up our profit function. So the profit function P of x is just equal to the revenue function R of x minus C of x. And then after that, we are going to evaluate our profit function at 1,800. So our profit function is just equal to, our R of x is 18x, and then our cost function is 10x plus 10,000. Simplifying this, we have 18x minus 10x minus 10,000, and 18 minus 10 is equal to 8x minus 10,000. This is our profit function. Then evaluate this at x is equal to 1,800. So we have 8 times 1,800 minus 10,000. So calculating this will yield 4,400. So the profit is $4,400.